In today's notes, let's look at Pythagorean triples and some applications of the Pythagorean theorem. So the Pythagorean triples are three positive integers, a, b, and c, such that they work in the Pythagorean theorem. A squared plus b squared equals c squared. And I just want to highlight these are positive integers. Integers are whole numbers. So here are a couple examples. 3, 4, and 5. If I were to square 3 and square 4 and add those together, does that equal 5 squared? Well, yes. 9 and 16 equal 25. That's what makes them a Pythagorean triple. Here's one that doesn't work. 6 squared plus 7 squared does not equal 9 squared. So let's just check this out. 36 plus 49 does not equal 81. Let's see, 36 plus 49 add up to, well, 85. So this is not a Pythagorean triple. Okay, here's a couple more examples of Pythagorean triples. 5, 12, and 13. This would be 25 plus 144 equals 169. That works. 8 squared and 15 squared is equal to 17 squared. That one works. Also, multiples of 3, 4, 5. If I were to double 3 and I'd get 6, double 4 and get 8, and double 5 and get 10, this would be a Pythagorean triple. And so I just doubled this, or multiplied all these guys by 2. If I multiplied these guys by 3, I would have 9, 12, and 15. That would work as well. We also can look at multiples of 5, 12, 13, because 5 squared plus 12 squared is equal to 13 squared. How about 10 squared plus 24 squared is equal to 26 squared? That'll work. Or if I multiplied them by 3, 15 squared plus 30 squared is equal to 39 squared. And multiples of 8, 15, 17. How about 16 squared plus 30 squared is equal to 34 squared? Or times 3, 24 squared plus 45 squared equals 51 squared. So your multiples are also going to work out. Let's take a look at some word problems now. We have a rectangle has a length of 12 and a width of 9. Find the length of its diagonal. Always, always draw your triangle. Always. Well, in this case, draw your figure, because we actually have a rectangle here, but we're about to get a triangle. The rectangle has a length of 12 and a width of 9. Find the length of its diagonal. There's our triangle. So across the box is your hypotenuse. So this guy's your hypotenuse, or your C. And then A and B really don't matter how you organize those. So 9 squared plus 12 squared is equal to the hypotenuse squared. 81 plus 144 equals C squared. If I add 81 and 144, I get 225. And if I take the square root, C is equal to 15. All right, so that's your diagonal. The next example says find the length of the side of a square. Okay, so again, we're not drawing a triangle yet. We're drawing a square. And a square has 4 congruent sides. It has a diagonal with a length of 12. So here's my triangle. And we know that this diagonal is 12. Okay, so it's a square, so both of these are the same. If you wanted to call them X or both A, but they need to be the same. So I'm just going to call them X. So X squared plus X squared is equal to 12 squared. So this is 2X squared is equal to 144. Divide both sides by 2, I get X squared is equal to 72. And if I take the square root, all right, so I could leave it as just X is the square root of 72. I could also do a factor tree. 2 goes in 36, 2 goes in 18, 2 and 9 and 3 and 3. And we're looking for groups of 2. All right, so I have a 2 and a 3 that come out. So 2 times 3 on the outside. And I've got this one single 2 that's on the inside. So this is 6 roots 2. I could leave it like that. If I wanted to get the approximation, I would go to decimals. It's an app on my iPad that I've got. And let's see, 6 roots 2 is about 8.49. So it's approximately 8.49, 8.5. Let's do a few more examples. This time we have some pictures. And let's start by just labeling. It says solve for x. Well, I know that's 10, so I know this guy is 10 right here. If I just take one side of this figure, it's a right triangle. I know it's a right triangle because I've got that right angle right there. Okay, so I'm going to call this guy, let's see, across the box. This is my hypotenuse, so this is my C, and the A and B don't really matter, so I'll call that guy A and that guy B. And so A squared plus B squared is equal to C squared. And so 144 plus B squared is equal to 225. And if I subtract 144 on both sides, this is equal to 81. And if I take the square root, B is equal to 9. So I know that this little piece, let me change my color, from here to here is equal to 9. So B is equal to 9. Well, it's a mirror image on the other side, so I know that this piece is also 9. So I've got a 9, 9, and a 10. That's 18 plus 10. The whole side is 28 units. All right, so let's do another example. Let's see, this is 8. So this piece is 8. It's definitely not drawn to scale. So I know that this piece up here is 2. If I want to find out what x is, well, here's your box. Here's your across the box. So we know this is the hypotenuse or the C value. And A and B really don't matter because you're squaring and you're adding, and addition is commutative. All right, that just means you can change the order. It doesn't really matter. A squared plus B squared is equal to C squared. So 4 plus x squared is equal to 144. X squared is equal to 140. And if I take the square root, x is the square root of 140. Let's see about a factor tree. So this is an exact value. Let's see if we can simplify that root. 2 and 70, 2 and 35, 5 and 7. Okay, so I have one pair of 2's that come out, and 35 goes back under. Here's a simplified root, and let's see what the decimal approximate would be. Square root of 140, go back to Desmos, square root 140, and it's about 11.83. And so this is approximately 11.83. And that's what the base of this triangle is. Okay, 2 more examples. Let's see, what do we have here? Well, if this guy is x, we know over here is x as well. And I'm looking at this right triangle right here. Oops, a little wiggly. And so across the box is your 15, that's your hypotenuse, or your C. And we can just call this A and B. So A squared plus B squared is equal to C squared. 100 plus x squared is equal to 225. So x squared is equal to 125. And so x is the square root of 125. I'm just going to go ahead and get an approximate. X is approximately square root of 125, 11.18. And one last example. Okay, so let's see, what do we have here? Looks like this guy would be 3. So we have 2 congruent triangles. And so I'll just do Pythagorean theorem. Let's call this guy my A. Let's call this guy my B. And across the box is my C. So 3 squared plus 6 squared is equal to C squared. 9 plus 36. And 9 and 36 make 45. So C is the square root of 45. If I were to do a factor tree is easy on this one. Let's see, 3 and 15, 3 and 5. And so I have a 3 that comes out. So C is also equal to 3 roots 5. And C is approximately square root of 45, 6.7. All right, and that does it for our notes for today on Pythagorean triples and applications.